Now we're going to look at what's called the future value of an annuity and a little bit later sinking funds. A sequence of equal payments made at equal periods of time is called an annuity. We've never done equal payments. The only thing we've had was that P, that value that represented how much we deposited right then and there, and it was just a one-time payment. So in this example, I start looking at using an old formula, and then we'll have a new formula that will take care of all of this, which is great. So in this example, we want to deposit $2,000 at the end of each year for 5 years in an account paying 7.25% compounded annually. Now this N is very important, and that'll be coming up here in just a bit. So if we deposit $2,000 at the end of each year, I'm actually doing a compound amount formula, but I have to do it for each individual payment because they're in there for a different amount of time. So we did it for annually, and this one, if you remember, is going in at the end of that first year, which means technically it's only in there for 4 years. So if you put this in your calculator, you should come up with this. Now at the end of year 2, that money is only in there for 3 years. That's the interest along with the prior deposit that we're going to have in there, or this deposit, not this one, because this is what the money will end up being 5 years from now. End of year 3, well, it's only in there for 2 years, so this money will grow to that amount. End of year 4, notice 1 year it's going to be in there accumulating interest, and that will grow to $21,000 or $2,145. The very last payment, because it said at the end of each year for 5 years, the very last payment is at the end of the 5th year. It gets no interest. It goes in right at the tail end. So if you add all of these up, it'll come up to be this. Can you imagine doing this for like 20 years? Oh my stars, it'd take forever. So we do have a nice formula that we're going to look at. This is called future value of an ordinary annuity. It's called S. It's different from A. S to me is a series or a sum of payments. A series of payments. R is payments made at the end of the consecutive interest periods. So you see, we had an A in our other formula, but that was when we only had a one-time payment. This one, we have a series of payments. This R, N, and T, like what we knew in the past, same thing here. Little bit different formula, and how I have to work at VI calculator is a little bit different. I will show you. So from the prior example, my payment was $2,000. The interest rate was 0.0725, N was 1, and it's going in for 5 years. So I put everything in the appropriate position. So now, because I've got this, the R and N in 2 locations here, I have to go about it a little bit different way. First thing I want you to do and start practicing is put this 0.0725 divided by 1, R divided by N, and store it in your calculator. So 0.0725, I know you can divide by 1, but I need you to get in the habit. If it was semi-annually or quarterly, you hit STO, and then I'm going to put it in for X, and then hit enter. Now, order of operations dictate I have got to get an answer in this bracket, so I've got to go to my numerator first. So parentheses 1 plus, remember I put this in for X, so I don't have to type all of that in, raised to the 5th power minus 1. Do your whole numerator. Now that number belongs here. I now have to divide that by what I put in for X. So divide by X. So that number belongs in this bracket right here. If you want to do, pieces at a time, that's up to you. But I want you to keep every decimal until the very end when we're going to round for money. So now all I've got to do, since that number is in here, I need to multiply it by 2,000. And if you'll notice that and that matches up nicely. Let me move my little boxy thing. Saves a lot of time. And a lot of this stuff we already knew. R is payments, though, and S is my future amount. And think about a series of equal payments. Let's see what I've got. First couple of problems in your homework talks about interest rate per period, and that's what the book calls I, and also number of periods. And remember, I'm looking at this because, there's some problems on the homework. I want you to use these formulas, because this is another formula that needs to go into on your formula sheet. So you see, the book would have I here, and then they would have just an N here. That's too much stuff to remember to me. But we'll go ahead and do these problems. For problems 1 and 2, find the rate per period, that's this one right here, and the number of periods for each loan at the given annual rate. So semi-annual deposits of $2,000 are made for 15 years into an annuity that pays 8.5% compounded semi-annually. So if I have to find my rate per period, there's my little formula. And I won't be asking you these on the test, but it's a good practice because, again, you have to understand what your number of periods are, or your period, the N value is. So in this problem, I'd have 0.085 divided by 2, and that would give me that. So it's 0.0425, that's my interest rate per period. It also wants the number of periods. So it's N times T. N here is 2, time is 15, so that should give me 30. Quarterly deposits, quarterly means 4, of 1,650 are made for 18 years into an annuity that pays 7.6% compounded quarterly. So our rate per period, R over N, and then be 0.076 divided by 4, and that should give you that. That's my interest rate per period. Now number of periods, N times T, that would be 4 times 18, or 72. Okay, let's get another problem. The USG Annuity and Life offered an annuity that pays 7.25% compounded monthly. If $1,000 is deposited into this annuity every month, how much is in the account after 15 years, and how much of this is interest? Okay, well, that's my original formula that I had earlier. My S equals R, and then that big bracket. So I need you to put the information in where it needs to go. Now it says how much is in the account after 15 years. So the 1,000, notice, deposited into this annuity every month. So the 1,000 is my R, and you know what the R, N's, and T's. So put everything in where it needs to go. Now let's go practice this one. I'm going to put 0.0725 divide by 12, store in for X, and enter. Go do your numerator, parentheses 1 plus X raised to, I'm going to let the calculator multiply it out. Remember, you've got to put those in parentheses, minus 1. That's my numerator. I've got to divide that by my denominator, which I have put in for X. Now I've got to multiply that by 1,000. So we should have $323,943.07. That sounds great. 15 years. But guys, it's not 1,000. We really have to figure out, and this is the reason for this question, how much of this is interest? Well, we got to figure out how much did we pay in all. So first thing, interest earned. So now that's what it grew to, and I've got to subtract out how much we paid in. Now check this out. 1,000, but how many times did we do that 1,000? Every 12 months. For how long? 15 years. So if I do my 3, 2, 3, 9, 4, 3.07 minus, and I've got to take, now technically I don't need parentheses, but I really wanted you to see that we've got to figure this out. Because this is a series of equal payments. This particular thing is $1,000 every month for 15 years. And it being an annuity, what they usually do with those, you know, if it's an IRA or a 401k, you can put this money in and you're not charged for that. And later on, after you retire, you know, you can get increments of this. So I believe that's it for this particular video. So you got some problems to do. Thank you.